We are Group 19 with topic Smart Home Security System. Here are my team members. I would like to start with the background information, history and future trend of Smart Home Security System. Smart Home Security System is a concept of managing home security system with cloud technology in order to strengthen the home safety. It aims to protect our home and loved ones. According to the estimation of research, the global markets of smart home security system will exceed $75 billion by 2023. There are many technologies applied in smart home security system, and I would like to introduce some. The first technology is sensor technology, which can receive and collect the data around the environment. For example, smoke sensor and CCTV. For communication technology, it is aimed to integrate the devices in the home security system. IoT and cloud services are the example to connect the devices so that they can work together. The analytic technology can help to detect and analyze the dangerous element received from the sensor. For example, Amazon Recognition has their own training database that can help to detect the dangerous label and give the response to users. Here is the history of smart home security system. The ancient security system first come in form of moats, drawbridges, and guard dogs. They have same characteristic, which is protecting our house. In 1853, the first burglar alarm is invented, but it is not popular until the end of World War I. In 1940, the video surveillance technology is invented, but is too expensive. Until 1969, Merriam-Webster Brown patented a video-based home security system. The home security system became less expensive and affordable in 1980. Up until 1990, home security system is hard to scale up and install due to all of them were hand-wired. When Wi-Fi entered 1997, the camera can transmit video stream wirelessly and remove the hand wiring issue. I believe the Wi-Fi sensing technology will be implemented in future. The home security system can analyze through the wave movement of Wi-Fi in houses. Besides, all the system in the neighborhood will be managed in the cloud service, so when one of the dangerous event happen like break-in, fire, robbery, other neighbors can give their hands. Artificial intelligence will be introduced to monitor and control home security remotely. Now is the problem statement and objective. We can notice that the traditional security system alert the user when a breach has occurred. It is too late to prevent a dangerous event like break-in. Thus, provide real-time or even early notification is important to secure the house. Besides, the crime increases when there is no camera or sensor can detect the illegal event. The criminal thought their behavior will not be recorded, so tragedy happens. Thus, our objective is developing a smart home security system that can detect dangerous elements around the house area with existing cloud provider.
Now I will talk about the architectural diagram of our smart home security system. First and foremost, there are two input data. First is sensor data from temperature sensor, smoke detector sensor, and grass break sensors. The data will be connected to the IoT core via credentials such as private key and certificate. Second is the video frame that are captured by the surveillance cameras. A series of video frame and sensor data will be sent to Amazon S3 bucket and IoT core respectively every few seconds. AWS Lambda will be triggered when sensor data is published to the AWS IoT core. In our solution, recognition is used to automate the image analysis upon the video frame. If there are dangerous labels detected, the labels will be stored. Action will only be taken if these labels are detected within a 30-minute time frame. Amazon DynamoDB is used to store the detected dangerous label, sensor data, and flag to prevent duplicate warning from sensor data. All the warning messages sent out to the user will also be stored in a table using Amazon DB. Amazon SNS will be used to fan out the message to the user if dangerous event occur. Finally, the user will be able to view all the historical events in the AWS Amplify hosted web application. The Amazon Cognito hosted UI is implemented in the web application for the user to sign up for an account to sign in to the web application. After the user sign in, Amazon API gateway with Lambda integration is used to fetch data from the Amazon DynamoDB and sends a response. User will be able to access data stored in Amazon DynamoDB.
Good day, sir. So the first step to be done in our solution is to publish the input data such as the sensor data and the video frame captured by the surveillance camera into the relevant AWS services such as AWS IoT Core and Amazon S3. So now I will explain on how we can achieve this goal. So the first thing is to create a new thing. Then we also need to attach a policy to the thing. So the policy here is about the control access to the AWS IoT Core data, and basically we just set up the policy action to IoT accessories. This means that we are allowing all the IoT action. Then during the registration of the thing, we need to download some of the required credentials to be used in our coding. Then the first thing is the certificate and private key, and also this Amazon root CA file. Besides that, we also need to go to the rules here, and we have created one lambda rule. So basically this lambda rule is used to set up the action to be triggered once the MQTT topic accept the message. So the SQL statement here is select all from sensor data. So the sensor data here means the topic to receive the message, and this action here is what happened when the rule is triggered. So basically we are setting the message which also the dummy data to the lambda function. So now let's see our code here. And before that, we also need to get the endpoint. This endpoint is used to establish a connection to the MQTT. So we can get an endpoint from here. So click on the setting. And so this is the endpoint. So the first thing is we have get one of the video. This is about the fire incident, and this coding here is to chop the video into video frames. And so for instance, let's say I delete the video frames here first, and then let me run the code right now. So as you can see, the video has been chopped to several video frames, and so these are the fire incident of the video. And also this is the dummy sensor data which have been created by us. It is composed of a JSON array structure, and in every few seconds we are going to send one of the JSON object along with one of the video frame here to the relevant AWS services. And besides that, this loop will be end when we have finished publishing all the video frames here. And there's a reason why we want to separate the video frame with the sensor data. This is because the maximum payload size that is allowed in the MQTT is only 128 kilobyte. However, when we encode our video frame into the base 64 type, it might exceed the limit. So that's why we need to separate them, and we are going to publish the video frame into the S3 bucket directly instead of sending them to the IoT core first. And so this is the function we defined to publish the video frame into the S3 bucket. And also this codings here is about how we get the dummy data, and also how we publish the dummy data into the IoT core and send to the MQTT topic. So now for demonstration purpose, and so the first thing I do, I will go and erase all the frames first. I just want to show the flow of how the message and the video frame is published to the respective AWS services, which are the AWS IoT Core and also the Amazon S3. So let me run the code right now. Okay, so now let me run this. So basically now I am publishing this video frame along with the dummy sensor data. Alright, so the flow has been completed, so let's view from here. So as you can see, so this message is the sensor dummy data, and the MQTT has accepted the message as the topic here is the sensor data. Yeah, and also for the S3 bucket, so I'm sending the image to this directory, my email with the area living room. So let's navigate to here and living room, and yeah, so this is the image. So you can see that the image here is matched with the frame 1. So this is the AWS Lambda, and so this is the Lambda recognition function created by us. So this function will be triggered when the sensor data has been received by the topic. So there are two main things to be done at here. So the first thing is to process the video frame, and the second thing is to process the sensor data. So now let's talk about how we process the video frame first. So notice that we have this object watch list. This list is used to store some of the dangerous labels such as bomb, dynamite, fire, weapon, snack, and so on. Besides that, we also will be fetching the video frame from the S3 bucket, and we will be fetching the latest uploaded image. And then we will use the Amazon recognition to do the recognition upon the video frame. Then, if any dangerous labels is found by referring to the object watch list, then we will be sending the message to the user through the SMS method. However, there are some conditions here. I will talk this inside here. So let us navigate to the DynamoDB and let's dive into this table. This table is known as alert history table. So as you can see, this label list is used to store about all the label name with some attribute inside. This is basically a JSON array string. So for example, let's say the latest video frame now, using the recognition service, we have detected a label called gorilla. Then let's say the timestamp now is 18th of April, so we know that the timestamp have exceeded 30 minutes, so we can make sure that this is a new event, and we will send a new message to the user to alert them. However, let's say currently the timestamp here is also 18th of April, and also the timestamp between both of them is less than 30 minutes. This means that this event is the same, and so we no need to alert the user. Then let's say the current video frame, it detected one new label such as dynamite, so we will be alerting the user about the label, and also we will be updating the label list for each time the lambda function is triggered. So let us talk about how we are going to process the sensor data now. So we will be fetching the sensor data from different sensors such as temperature sensor, grass break sensor, and also smoke detector sensor. And also, we are having different threshold for the temperature data. For instance, if the area is living room, then the threshold we set is 43 degrees Celsius. Meanwhile, if the area is kitchen, then the threshold value we set for temperature is 50 degrees Celsius. We have all these threshold value by referring to a literature review. The next thing is that we have two different use cases here. For the first use case, if the temperature data exceeds the threshold plus the smoke detector sensor returns a true value, then we will be alerting the user. The next use case is if the grass break sensor it returns a true value. This means that the glass has been broken inside the house, and also we need to alert the user. And again, we have some conditions on whether we should alert the user or not. But before that, for each run of the lambda function, we will be fetching some of the frags stored inside the table of DynamoDB table. So this is the frags. Is living room temperature sensor alert, and also is kitchen temperature sensor alert. Okay, so first of all, we will be fetching the frag inside the lambda first. And let's say if the frag we fetch now is true, this means that currently there is a dangerous event happening. So even if the sensor has detected a dangerous event, we will assume that this is the same dangerous event, so we will not be alert the user again. Then let's say now the frag we fetch from the DynamoDB table here is false. This means that currently there is no dangerous event detected. Then if we have detected the dangerous event based on the sensor data output, so now the first thing we do is we will change the flag to true, and also we will alert the user. So when the next sensor data comes in, again it will exceed the threshold and it need to alert the user. However, since now the flag is true, so we know that this is the same dangerous event and we will not be alerting the user again. Then if the flag here, let's say now the sensor data, it returns a normal value and there is no any dangerous event, and then we also will check the flag. If the flag is true, then we will change the flag to false back, so that the next time we detected the dangerous event, we can alert the user again, and by that time we will updating the flag from false to true again. For the glass break sensor, we assume that once the glass break sensor has returned a true value, this means that the glass has been broken, so we are not going to store a flag for it, and it only will be detected for one time. So basically this is the entire flow of how we process the sensor data. So before I end my section, so I also want to introduce the table created by us, which is the alert data table. Basically, this table is used to store all the alert message that has been sent to all the different users. We send out the message to the user using the Amazon SNS. And also, let's dive into one of the record here. So as you can see, we have some of the attributes here. Email is for us to identify whether this alert message is belong to which user, and this timestamp is for us to filter the records based on the date, and this is the message to alert the user. These records will be used inside our web app.
Next, I would like to talk about the AWS Amplify, AWS Connector, and also API Gateway to retrieve data from DynamoDB. First, we have created two web pages. The first web page is the page that forwards the user to the Amazon Connector hosted UI to perform sign-in. The second web page is the page that contains the functionality that the user can use after they have signed in. In order to use the Amplify hosting service, these web pages will be deployed to the AWS Amplify to get the domain URL to access the web application. After that, AWS Connector is implemented for user authentication and user management. This is the required attributes when the user registers a new account. Minimum password length, password policy are set, and also use email to do account verification. All user accounts can be viewed and managed here. Next, the callback URL and the signout URL are set. The callback URL is the main page of the web application where the user is redirected after successful sign-in. The signout URL is the sign-in page of the web application that is where the user is redirected when the user signs out of the web application. This connector is using the OAuth 2.0 to do authentication so that the user will get an OAuth token if authenticated. The token will be used to do authorization when send the API request. And this is the Amazon connector hosted user interface for user to sign in and also sign up to access the web application. Now I go back to the AWS Amplify to run the web application. This is the first web page that forwards the user to the Amazon connector hosted user interface to perform sign-in. The user can sign up a new account so the user will need to do the email verification. As you can see, a new user is created. This is the second web page. When this page is loaded, it will send the API request to get the total numbers of detected. Also, there's a button for the user to click to check all the historical data that the application will send another API request to get the historical data based on the date. There is also a sign up button for the user to log out their account. Next, I will explain the REST API request. This is the path when the client sends the API request. When the request is sent, it will do the authorization first, and then go to the Lambda function to process the response data and then send it back to the client. The authorizer is set to the API for authorization. So this is to ensure that the sender they have permission to access the data in the database. When the user sends the API request, the access token is put in the header of the request for the authorizer to do authorization. This access token is generated if the user is authenticated during sign-in. Next, I will show you the Lambda function that processes the response data. This is the code to query the data in a DynamoDB for a specific date with the email address. Email address is the partition key stored in the DynamoDB that uniquely identifies the user, and also the date is used to filter the data. Then it will return the response data. Lastly, I will show you the overall process. Now I will publish this video with sensor data. So the user will receive the SMS message if a danger is detected. There are 3 incidents detected for today: glass broken, abnormal temperature, and Amazon recognition detects a fire outbreak. Then the user can access the web application to check the historical data. The application will show the historical data for today, the time, the message, and also the CCTV image. And then the user can also choose different dates to check the data. Now, I will test the system with different scenarios. That's all for our presentation. Thank you.